All right, so let's get this going. Just want to say thank you, Dr. Hezzy. Appreciate everything. Your lectures and everything have helped me out a lot in understanding this material, going over it, especially abstraction and multiple inheritance, which we went over in our previous lecture on Monday night. Yeah, it's just been super helpful. Quizzes, assignments, everything's kind of put everything together, kind of gotten it going for me. I learned by writing code. I think that's a lot of us is we're coders at heart and we're computer scientists at heart. So we want to learn by doing an implementation along with reading and understanding the conceptual side of it. So yeah, here's the assignment. A little confused on the due date. It was posted and announced tonight, which would be the March 5th, and it was posted, I believe, at 8:20. I've been working on it since. Kind of feel good about it, so I figured I would just wrap it up and present it. Previously today, I've already kind of, because you brought up you were going to do this PowerPoint, and we brought up some of the concepts and started working on the code and everything in a generic asset. And now I'm putting it together from the guidelines and everything. So, all right, moving on. So we'll first move on to mass testing Java. You wanted us to basically write everything as you have it here. We want to write two methods with abstract class operations, int sum, void show results, create three children classes, even numbers, prime numbers, odd numbers, obviously makes sense. You wanted us to do 10 even numbers, 10 prime numbers, 10 odd numbers, and then showing the sums as shown below as output. And I will show you how I did so and how I went about it. So for this one, I have, here it is. So we'll go over all this. So obviously, this code defines an abstract class operations with two abstract methods, which will be sum for calculating the sum and show results for displaying the numbers and their sum. The even numbers, prime numbers, and odd number classes each implement these methods according to the specifications. Even numbers calculate and display the first 10 even numbers and their sum, and prime numbers does the same in correlation, and then obviously odd numbers the same. This approach demonstrates the use of abstraction and method overriding, as well as principles of encapsulation by hiding the specific way each type of number is handled and summed up, as you can see here by the algorithms created and using kind of just integers to basically sum it up and provide the output as a print statement. The provided Java code just showcases an abstract factory pattern throughout an educational example that just demonstrates how to manage different types of numerical sequences, basically even number, prime number, odd numbers, using abstract classes and inheritance. So let's pretty much break down this code. The abstract class operations serves as basically a template for all operations. Int sum is basically, go up here if you can see. So int sum is basically the method to calculate and return the sum of the specified sequence of numbers. The actual calculation logic depends on the subclass implementation. And then we have also the void show results. This method is responsible for displaying the sequences of numbers and their sums. The specific sequence and its presentation logic are provided by the subclasses. These abstract methods enforce a contract, basically. Any subclass of operations must provide concrete implementations for both methods, ensuring that each type of operation can calculate a sum and display results as we wanted and as given by the parameters. Subclass implementation operations. So the even numbers sum implements the logic of calculating the sum of the first 10 even numbers. We use a simple loop. So I'll show you that. A simple loop of sum of numbers, which are generated by implementing the loop index I by 2, since every even number can be expressed as 2 times some integer. And then show results, which displays the first 10 even numbers and their sum. It iterates from 1 to 10, printing each even number calculated as 2 times I. After listing these numbers, it calls sum to display the total sum. Then switching over to prime numbers, calculates. So for sum, for this one, calculates the sum of the first 10 prime numbers, because generating prime numbers programmatically basically allows more complex than generating even numbers or odd numbers. This method uses a predetermined array of the first 10 numbers and calculates their sum. This was definitely more difficult and took kind of research and understanding of the algorithm. And then it goes to show results. Similarly to even numbers, but instead it generates prime numbers on the fly. It iterates through the hard-coded array of the prime numbers and prints them, and then displays the total sum of the method. So, and then last but not least is the odd numbers, which calculates the sum of the first 10 odd numbers using a loop. Each odd number is generated by the formula 2 times I plus 1. Odd numbers. So you got to add that plus 1. It's similar to even numbers, but adding plus 1 makes it obviously an odd number, ensuring that all generated numbers are odd. And then the show results prints the first 10 odd numbers by applying the same formula used in sum for each iteration, followed by printing the total sum of these numbers. And then moving to the last would be obviously the class math underscore testing. This class contains the main method, the entry point of the program. It demonstrates the use of polymorphism and the principle of abstraction. It creates inheritance of even numbers, prime numbers, and odd numbers, although these objects are instantaneously from concrete classes. They are reference for using the abstract class type operation. This approach highlights polymorphism, which we learn in algorithms, where a single variable type can refer to objects of different subclasses. The importance of this approach is that encapsulation and abstraction, the operation class encapsulates the concept of a numerical operation. Abstraction, the details and the requirement subclasses to provide specific implementation. This hides the complexity from the user. Polymorphism, on the other hand, the use of the abstraction class to refer to the objects of its subclasses, allows the math underscore testing class to iterate all types of operations in a uniform manner. This makes the code more flexible and easier to extend. It just makes it more reusable, more scalable. This code is basically just structured in a way that is object-oriented programming practice. Is basically the way we're taught at CBU to program. And I try to implement that in my day-to-day coding and in this iteration. So this would go over all of this conceptually. And now we will move over to my PowerPoint, which I should have here. Here we go. So I'm just going to touch this very briefly. So we will go from beginning. So basically just an overview of this PowerPoint, and then why is it essential, goes over the abstract class interfaces and kind of defines it, tells you why this is essential, and basically the two ways that I believe it is. And it contains basically the regular methods of the body and the base of the subclasses, extends it, interface, etc. And then kind of continued several reasons, because simplicity, modularity, reusability, maintainability, and scalability. As a coder, we want our code to be reusable, scalable, and simple. Those are key crucial concepts that we have been kind of drilled into our head about coding. And then describe how to implement abstraction in Java. Obviously shown in our code before, but it's just kind of going over a more wordy sense of this. And what is the difference between abstract class and concrete class? So I first go over abstract class and what defines it. And then I go over concrete class, the definition, how to use it, implementation. And then I go over key differences. So basically, abstract classes cannot be instantized. Like, it can't be instantaneously implemented, basically, is what I'm trying to get at. Can contain abstract methods without a body, used as a base class for other classes to extend. And then concrete classes can be instantaneousable and can contain no abstract methods and can be used to create objects with fully defined behaviors. And then I kind of just do an overview of these. Illustrates how to achieve multiple inheritance in Java. Just go over this and the steps. Define how to do it, define how to implement, and then define usage in modern day Java. Because there's so many forms of Java, I wanted to show kind of how we would do it in current day Java and our models that we use now. Then describe how to achieve an abstract factory pattern design. We just kind of did that. So let's go over that. And then kind of the importance of why it is decoupling, consistency, scalability, and principles of inversion of control. And kind of go over in detail what those mean in my sense, and kind of also in a generic sense. Show obviously the code, and then show the output screenshot. So that'll be it. God bless Dr. Hezi. Hopefully this suffices, and hopefully this is good enough. If you need more from me, feel free to ask. Sorry, it's kind of late, so it's kind of dark. And yeah, just look forward to seeing you next week, and let me know if you need anything else. God bless. Bye.